Hi, I'm Shane, and today we're going to be using our 96-inch hydraulic soil conditioner. This unit shown here weighs about 1,350 pounds. The backbone is a 4-inch by 8-inch rectangular steel tubing with 1/4-inch wall thickness that runs the full width of the frame. The frame on this float model is coupled to the mounting plate with a 4-bar linkage. What this allows you to do is change the depth of cut while you're working with the conditioner. Okay, so I want to demonstrate how our system allows you to change the depth of cut on the fly from the cab. The way this is accomplished is by the 4-bar linkage that connects the mounting plate to the subframe. Because it's flexible, you can simply change the angle of your mounting plate and that'll adjust the geometry to either raise and lower the rotor. When the skid steer drives through rough terrain, such as these ruts in this field, the motion transmitted to the rotor is actually counteracted. So when the skid steer axle goes down, the rotor actually goes up. It's the opposite direction. What that means is it helps you to maintain a smooth cut. Okay, so we get a lot of questions about how a soil conditioner works to recondition a driveway. So I have a driveway here that's rather old. It has a typical driveway shape. It's got ruts where the wheels track for the vehicles, and it's got high spots on either side and a high spot in the middle. What happens is this traps the water and makes mud puddles, and it just gets worse. So what I'm going to do is I'm going to use the soil conditioner to shave off the humps on the sides and bring that to the middle to create a perfectly crowned road that helps shed water. So this will probably take at least 4 passes. I might take 1 pass down the middle first just to work up the middle of the road, and then I'll take a pass from the left and the right with the rotor angled to one side so that I can push the material to the middle of the road. Then I'll take the final pass and knock down that hump in the middle and kind of level it out. With respect to the size of the driveway, this driveway here is about 160 feet long, give or take, and the 4 passes only took us 6.5 minutes. And so you can see the results. We have a nice gradual crown out to the road. With respect to the shoulder angle, I wanted to point out that because our flexible mounting system here has some oscillation to it, the angle is dictated strictly by where you run your downhill wheel. So I was running it on a part of the shoulder here to just give me a few degrees of cut. If I wanted to be more aggressive, I would just move further to the left. These wheels don't necessarily line up with the wheels on the skid steer loader, but since there's oscillation, the drum, the rotor, and the frame are independent of the skid steer loader. It really only matters where you run these wheels, not where the skid steer wheels run. So that's a really nice feature about the floating mounting plate. We also offer this soil conditioner with a rigid mounting plate, which ties the mounting plate directly to the subframe. This unit is equipped with our optional hydraulic angling. This allows you to change the angle of the drum up to 25 degrees either direction while you're working. This is very handy for windrowing material or moving topsoil from one side to the other. Now we're going to be in a wheat stubble field that was chisel plowed last fall but hasn't been tilled yet this spring. The ruts in here are, probably up to 4 inches deep. So what I'm going to do, since there's a lot of rock in this area, I'm going to simulate that we'd be going in here and prepping this for either sod or planting grass or something. The first pass has already yielded a lot of rock. So this is rock that can't be drawn over the top of the drum. It just gets pushed and pushed along till the end. So you actually do collect rock the first pass. A lot of these are larger rocks. Now the second pass over, we're not going to till as deep we're just going to tickle the top of the topsoil and push the smaller rocks off to the side. So we'll still see a windrow on each side, but just gives you an idea of the rock that can be collected just on the first pass. Okay, so we just finished our second pass in this small field. This field is this area we dug up here is only about 120 feet long, and we've done 4 passes wide. So there's 2 passes worth of windrowing in this windrow right here. You can see the rocks that we dug up are the smaller variety, and they run pretty much the full length right here. When I windrow, I usually windrow to the right side because that's the side without the motor, and I usually raise the wing on that side if I have wings attached. So you can see the nice result we get on the surface here. You get kind of this nice rough finish, but it's not really rough. That helps prevent wind and water erosion. So if you don't get back to this area the same day to plant it, a couple days later, it's still going to be there. The wheels themselves are made of solid urethane, so they'll never go flat. You'll never have to maintain the air pressure. And they're much larger than the competition models. This allows you to get better flotation in the soft material that you might be working in. The rotor on our soil conditioner is one of the largest in the industry. It's made up of a 10-inch diameter tube with 1/4-inch wall thickness. On this 96-inch version, we have 120 tungsten carbide tip teeth. You'll notice that they are not welded in straight lines across the drum, but rather in a spiral pattern. And what that does is keeps the torque on the motor very smooth. So the digging action is very smooth on the hydraulic system. Other soil conditioners out there, you'll find they have the teeth welded in straight lines. And of course, that's much easier to manufacture, but what you get is kind of a paddle wheel effect where you're kicking waves of dirt out in front of the drum, and that is loading your motor in a pulsating mode. So it's digging really hard when that whole row of teeth comes around, whereas with us, we have the same number of teeth engaging the ground at any one time. So one of the questions we often get is, how tough are your teeth? The teeth themselves were developed for mining applications. They're tipped with a very hard tungsten carbide tip, and what we did here was a little demonstration showing what happens when it goes up against a granite rock. You can see from the results here that we're actually taking out chips and scrapes out of this hard rock. The teeth themselves, I can't see any damage on them. These are the teeth here that were hitting the rock. So this demonstration proves that the teeth are very, very tough. We're using a Eaton 6000 series motor with a large enough displacement that gives us a large amount of torque and a lower speed. This gives us the best balance between speed and torque for doing digging and tilling operations. Our soil conditioner uses a direct drive system. What this means is it eliminates any kind of a chain drive for the rotor itself. Some of the competition uses a chain drive, and we've found that the chain requires a lot of maintenance and there's a lot of points of failure there. They use an oil bath system, so you have to maintain that oil, make sure it's clean, make sure it's not leaking. That side is always down, digging in the dirt, getting hit by rocks and such. It's really a lot of maintenance. Also, the spring tensioners that are used in some units sometimes will break, and when that happens, you don't know that it's happened in the cab, and if you continue to use the unit, the chain will jump on the sprockets and wipe out and wreck the chain and sprockets. So direct drive unit is much simpler, much less maintenance, and over time saves you a lot of money. The skid shoes on both sides are also bolted in place to make it easy to replace them if you ever need to. They can also be removed if you want to maximize the penetration in hard packed soils, such as a lawn that hasn't been tilled before. The bearing on the opposite side of the drive motor is a special type that uses a metal shield to protect the rubber seals from damage from anything that might be wrapped on them. Also on the inside of the plate, we use a second piece of tubing that fits inside of the diameter of the rotor, and that provides a labyrinth pathway which prevents heavy materials from wrapping on the shaft itself. So we have double protection on the shaft to eliminate problems that might occur when you have material wrapped on the shaft. I wanted to point out that we have a very heavy rubber mat both on the front side and the back side of this frame. What that does is it acts like a dam, so it keeps the material in front of the drum. This is important for times when you might be digging up dirt clumps, breaking them down. You don't want to have them recycle over the top too early. You want to have them broken down into a small enough chunk that can be easily seeded. So this is going to keep that material in front of the drum and keep it processing until it's small enough to exit over the top of the drum. And of course we have one on the front for forward operation, and we have one on the back for reversing operation. Landscapers that want to windrow debris and rocks off of a lawn, for example, this rubber mat is going to keep the rocks in front of the drum. So they'll keep collecting here and either exiting to one side or the other if it's angled, or you can just push them all to one end and then raise up and leave them on one end. So they're easier to collect, and also gives you a better finish on an area where you might want to lay sod or plant grass seed. Okay, so we just finished this area of this field here that was really lumpy. It's not exceptionally hard digging here, it's actually pretty soft soil, but I wanted to show that you can go in and on a first pass really knock all the high spots down and get it really workable so that the second pass can be a nice dress-up finish pass. So that's just what I'm trying to show here. And then we also show the difference between the standard flow and the high flow. In the finish, you really can't see any difference. I was maybe able to drive a little faster on high flow. It certainly threw more material around, which if it was dusty would be more of a problem, but certainly this machine works perfectly well on standard flow. That's what it's designed to do. So very impressed with how it worked. Be sure to check back later as we do more videos. Give us a call or check our website if you have any questions.